Okay, so last time we have seen some examples on Numpy, and today we'll continue a few more things on Numpy, and we'll try to make sure cover most of the topics. And worst case scenario, if you're running up to, if you're running out of time, we might go for search, sort, and filter for the next session, and then continue with pandas for week 8. So especially today's session, we'll be looking after this numpys again. I'll talk about something around data types, array copy versus view, shapes, reshape, iterating, join, and split. So let's say if you have more time, then I'll cover this last topics also. Then uh, it's not, we don't need to put much pressure on ourselves. So if it doesn't, we'll continue the last 4 topics and then the pandas for next week. And that means once we're done with the pandas, and most of the sessions of Python are all done. Okay. So this week with the week 7, starting ahead with data types, I think you guys have remember the NumPy. Last time we are talking about the numerical Python I discussed, right? So the same thing, continuation, we'll be talking about NumPy in this session. So starting with the NumPy, the numerical Python, we will be focusing on the data types, like in what are the different types of data which we can utilize it in NumPy, using NumPy. So here, NumPy data types in Python, by default, Python has these types of data types like strings, okay, integer, float, Boolean, and complex. So we do have some examples of the strings we need to be placing within the quotes, okay, and integers like 1, 2, 3, 4, or whichever, like in it could be -1 or +1 also, doesn't matter. And if it's a float, it will be like in 1.2 or 42.2 with the decimals. And if it is Boolean, true and false, and a complex, like it's like beyond a certain limit where we need to use a calculator also. Okay, complex numbers more than certain limit. So data types in NumPy has some extra data types also, and refer to the data types with one character, like I for integer, U for unsigned integer. We'll give some notations. So below is a list of all the data types in NumPy, other than those 45, other than 5. So I will represent for integer, B for Boolean, U for unsigned integer, F for float. We do have the C for complex float, M for time delta, small m, and capital M for date time, O for object, S for string, U for Unicode, V for fixed chunk of memory for other types. So we may not be using this. So we'll cover some examples today. Okay. So for example, if I'm giving an limit like 1, 2, 3, 4, and says np data, just a minute. So here, checking the data types of an array, the NumPy array object has a property called dtype. Okay, so that returns the data types of the array, right? Okay, yeah, just pausing. Yeah, I'm back. So here, what we're trying to do ourselves is we're talking about the NumPy array and the data types, right? So when we say print arr.dtype, it is giving us integer. Okay, is a 32-bit style in 32. So it's like a 1, 2, 3, 4, that number format, right? So we are asking Python, okay, like in what is the data type where the data value is present in the array? What are the different types? So the same case, we can pick up one more example, like when you run this. Okay, what is your D type over here, U6, something like that here, Unicode string. Okay, so it's a string, but a Unicode string, it's picking up. Okay, I think this is given a space, get the data type of an array containing strings. Yeah. Okay, so it's all based on what we're trying to type here, like an array of D type. Okay, but here we're given the quotes and the string values. Okay, here we didn't give the strings, so there's a difference. We put the same thing in the strings, again the data type will change. In same case, let me use the other format, creating array with a defined data types. That means what we're trying to do is, as you said, there is something called string also, right? There's S for string, right? We can also define. We can also define. So what we are saying is we use the array function to create arrays. So this function can take an optional argument, right? D type that allows us to define the expected data type of the array elements, right? So let me also see. Yeah, it's continuing recording, right? Yeah, that's good. So here, let's take an example. So creating an array with a data type string type. So how we are defining? So the format is NP is, so since we have imported the Numpy and the setting as NP, so we already discussed in the other classes, like instead of Numpy, we give the shortcut as NP, right? So NP dot array 1, 2, 3, 4 D type, yes. So when we say print that array and also the type, so what it is trying to say is, so it is setting up some values like in be 1, 2, 3, 4, okay, and also S1. So here it's a string type, right? So here let's say we are defining it. We're defining the values, like, and they're all set to the string category, and that means how many are there, like in D type? Yes, yeah. So in the same manner, if we need to assign some more things, like in something in a different format instead of the string format, if we can say like for I, U, S, F, S, U, we can define size as well. Example, okay. So what we are trying to do is create an array with a data type 4 bytes integer. Okay, this is called I4. I is for integer. This is what I have discussed here. I is for integer. We can define, right? And then also the byte space. There's something called the 4-byte integer. So when I say I4, right? So it is going to define in that fashion. So the same thing when I printed array, we're giving us 1, 2, 3, 4. And the type will be like an int format only, but the storage at the back end in the memory, so it will be stored in like on 4 bytes. Like memory, we talk about the bytes, right? So we're defining, saying that integer type 1, 2, 3, 4, and that to store with like an 4-byte space. So that's what we're defining here. So we have got a different examples. So let's pick up one more example. But in this case, what if the value cannot be converted, right? We are converting here integer with 4 bytes, and we are also giving a string, etc. We're converting to string and everything. So the other way around, what I mean to say is, for example, if a type is given in which the element can't be casted, then NumPy will raise an value error. What if it is not possible? So value error means in Python, value error is raised when the type of passed argument to a function is unexpected or incorrect. So example, what's happening over here is a non-integer string like a, right, cannot be converted to integer. Why? Because we are saying, okay, a is not an integer value, a is a string when you specify. So import numpy as np when I'm saying array of np dot array, okay, d type we're saying as integer type, but here this is not integer, okay. So then definitely we will get in value error. So invalid literal for int type with a base 10 of a. So how do I correct it? So the only thing is that it is giving us a hint saying that it is a value error. We can't define like that. So best thing is to replace it with the proper integer value. So when we replace 1 to the to test that information, okay. So the same thing, I replaced a with 1, and when I run it, okay. So let it let where is that converting? Probably I need to print it. Okay. So let me use the print command over here. There is no error message. Okay. See. So what I've done over here is instead of a, I did replace with 1, right? And I'm setting as a d type as 1. It says 1, 2, 3, right? So this is what it's printing the values 1, 2, 3. So the same case, converting data types of existing array. Okay. So the best way to change the data types of an existing array is to so here what I'm trying to say is converting data types of an existing array. The best way to change the data types of an existing array is to make a copy of the array with AS type method. Okay, the AS type function creates a copy of the array and allows you to specify the data type as a parameter. The data type can be specified using a string like F for float, I for integer, or you can also use the data type directly like float or for as I said like float and integer. Okay, just a minute. Yeah, sorry for the pause. Okay, so here what I'm trying to say is the converting data types. So how are we going to convert it? Right. So let's take an example. Change data type from float to integer. Right. So here what we're trying to do is we passing the values like 1.1, 2.1, and 3.1. Right. So we're giving the float values as an input, and I want the type to the integer format. So how we're going to do that? So here AS type is the method, right? So that's the reason I was talking about converting data type on existing array. The best way to change the data type of an existing array is to make a copy of the array with AS type function. So this is a function where we can change from one data type to another data type, right? So here, when I say, when I run this one, so what I'm going to get is, I'm going to get 1, 2, 3 only. The reason behind is, it is not giving us 1.1, 2.1, or 3.1 as an output. I'm just getting as 1, 2, 3. It is going to remove these floating values since I'm giving the type, like an AS type, like it has to convert the data type. So the first case, it is printing the array, and it is also the second case, it is printing the data type. What kind of data type is the integer one again. So the method is to use AS type. So that's what I've used it. So we can give one more example here. Okay. So here, what I am trying to say is change data type from float to integer by using int as a parameter value. So that there are two things. Either I give like an I, AS type as I, or the other way, instead of I can give as int. The same thing, same array, but the format, only the format is different. So when I say new array equals to arr.as type, so this time it is doing the same method, same process, converting the float values to the integer values, but we're giving us int. So either you can use I or int. So those are the two different formats to. So the reason behind is, for example, tomorrow, once you get a certain project requirements, there is a need that you need to convert from one format to another format. So in that case, we need to know that what are the different methods, how we can convert from one format to another format. So that is mandatory. If you're if you think that okay, no, what to do, then you need to go back to the data types, different data types, and understand the data types, then convert the data types, then learn the things. So instead, if you learn everything right now, then in the future programming, then it will be easy. So for example, let's talk about the Boolean also. Boolean, generally we talk about the true and false. The same format here. So in general, 1 or any numerical positive value will be treated as true. At 0 or the like in if it is 0, it will treat as false. So we are giving as AS type of Boolean this time. The same thing, print the new array and new array type. So here what is happening is 1 means true, 0 means false, 3 means true, and the data type is a Boolean, right? So that's what the difference is. So why we are saying is 1 and 3 as true and 0 as false. Okay. So this time we'll proceed to the next step of copy and view. Like we can give the command, like there is an option to copy and there is an option to view. And what is the difference between copy and view? So this will be slightly tricky one, but no need to get confusion. So I'll give the clear example. For example, array I'm giving as 1, 2, 3, 4, 5, right? And here I'm giving that x equals to array type of copy and array 0 equals to 42. As you all know, the first element start with 0, second with 2, 3, 0, 1, 2, 3, and 4. Okay. So here what it is happening here is when I print the array, what will happen is, so still there are two things which are happening here. So a of 0 is being replaced with 42. So here we got what are the elements we got is 1, 2, 3, 4, 5. When we assign array of 0 to 42, it is giving like 42 and 2, 3, 4, 5. But again, when I say print of x, okay, what it is giving is 1, 2, 3, 4, 5. So it is again replacing back again. The reason behind is there are two things can happen. So the difference between copy and view, the main difference between a copy and a view of an array is that copy means is a new array. Okay, and the view is just a view of an original array. So what will happen is the copy owns the data and any changes made to the copy will not affect original array. So this is the difference. So here we are doing only the copy. So that means there won't be any change. And any changes made to the original array will not affect the copy. So that is the reason. So it is, even though if you make any changes, it will not affect. That's what it is trying to say. And there is an option called view. We will be looking at view option at the bottom. So the view does not own the data and any changes made to the view will affect the original array and any changes made to the original array. So in this case, it will change. Okay. So what you have learned over here is, even though if I try to make any copy of the array, it will try to change in the first instance and the next time it will replace it back to the normal. So what they're saying, trying to say is the copy should not be affected by the changes made to the original array. So there is a need in future also when we do the programming, but let's see the view option, then we'll come to know why we are trying to utilize these options. View, make a view, change the original array and display both arrays. So what he's saying is to change the original array. So this is the original array 1, 2, 3, 4, 5. So how it's being changed means x equals to array dot view. When you add this line and then they say that array of 0 equals to 42. So when you print the array, you're getting 42 and the other numbers. And when you print x, you're getting the same thing. So what's happening is array 0 equals to 42 means 1 is being replaced with 42. So your view means, so the main purpose is it is going to change the array. It is going to change the original array. If I say 1, it will be the different case. Okay, let's try this, what it will happen. Okay, see, when I say array of 1 equals to 42, array of 1 in the sense, this is array of 0 and this is array of 1. So 1, 42, 3, 4, 5. See, that means whatever the array element we are trying to display over here to change it, it is going to change. If I say 0, this is 0th element, 1, 2, 3, 4. So if I say array of 4, okay, and let's rerun it. See what it is happening. All the first 4 elements is going to display, but it's going to change array of 4th element. So 0th element, zero. Okay. So this is a 0th element. This is a 1th, 2nd, 3rd, and a 4th element. So the 4th element has been replaced with 42. So this is the difference between view and if in the case when you use the copy, it won't. So we'll come to know why there is a difference. So the view should be affected by the changes made to the original array. Okay. So let's take one more example. So make changes in the view. Example, make a view, change the view, display both the arrays. So when I say import numpy as np, array equals to np dot array of 1, 2, 3, 4. So here also it says x of 0. That means first value change it to 31, right? The first value change it to 31. So what it is happening here is, so array, it's like a 0th value. So 31 and 2, 3, 4, 5, right? So here we're changing the values in the view, the same case as above. Whatever we're trying to do, the same case over here. So let's make the what we are trying to achieve here is the original array should be affected by the change of the view. Yeah, the same thing. The view will be uh, it's the same thing. The view should be affected. So here this is another example. Any other difference in this both the cases? There's nothing much difference. The both are the same. The only thing is that here there's a slight change. If you observe here, there's a slight change. So anyone noticed here? We are here saying that array equals to np dot array. That line is common in both the cases, right? This line is common in both the cases. The only difference is we are saying x equals to array dot view, and then we are saying arr 4. But here in this case, this line is also same, okay, and the third line is different. The third line is different. So here when we say array of 4, that means of 4 elements, whatever the 0, 1, 2, 3, 4th element will be changed. Here also the same case, but here we are saying x of 0. For example, if I say x of 44, okay, let me run this, and if I give the same value like in 42, and if I run this, see what is happening. The same format 1, 2, 3, 4, and 42, the same thing. The only difference of you made the change is here instead of array of 4, instead of for this one, this time I'm saying x of 4. That means anything, either you define array of 4 or x of 4, the reaction is same. That is what they're trying to specify here, right? So we can give in both the cases, both the format, right? So just a second. Yeah. So yeah, that's what the main difference is. So there is another way also what we are trying to say. I think view and so your numpy array copy and view. This is the only difference, but there's something beyond this copy and view. There is something called check if array owns the data. Okay, check if array owns the data means what we are trying to do is, so print the values of the base attributes to check if the value array owns its data or not, right? So what we're trying to do, as mentioned above in the other examples, copies owns the data and view does not own the data, but how we can check it? So this is all about the same thing of what we had discussed here, like in copy and view of the array. But how do we know that which is what, right? Here the same thing, we are giving a input command numpy as np and array of the elements defining as 1, 2, 3, 4. So here we are saying x equals to array of copy and y equals to array of view. So print x dot base and y dot base. So what it's happening here is, so when I say x dot copy means it's giving us none. That means it's not giving any values in it. Okay, that means it's not making any changes to the array. And when I say print y dot base, it is giving 1, 2, 3, 4, 5. So the difference is what we are trying to achieve over here is who is owning the data. Check if array owns its data or not, right? So here, when I say array dot copy, that means it doesn't own any data, right? And array dot view means it does contains the values 1, 2, 3, 4, 5. So every numpy array has the attribute base that returns none if the array owns the data. Otherwise, the base attribute refers to the original object. So this is what we are trying to say. So example, print the values of the base attribute to check if an array owns its data or not. So that is what we are trying to say here is who is owning the data. When we say array.copy, does it owns the data, or array.view, does it owns the data? So here in this section, y equals to array.view is owning the data 1, 2, 3, 4, 5. Okay, so we don't need to struggle a lot with this thing. Why? Because this only the options which we have it to understand what is the difference between copy and view, and who whether the array owns the data or not. But in general, shapes, we talk about shapes and numpy array shapes, which is a key topic, I would say, to focus on. So I think until here there is not much confusion. That's what I feel. So let's discuss with array shapes. Okay. So here, for example, what I've done is array equals to np dot array 1, 2, 3, 4, and also 5, 6, 7, 8. And this is simply nothing but the two-dimensional array. But I want to ask Python, like, what is a shape? Print arr dot shape. Okay. So it will calculate everything and it will say 2, 4, the shape of the array. Okay. So it's like an what do you say? We got 4 columns in it, right? Yeah. So that's the reason. 2D array and 4 columns. So print the shape of a 2D array. That's what we are trying to say. So numpy array shape means shape of an array. The shape of an array is the number of elements in each dimension. Get the shape of the array. Numpy arrays have an attribute called shape that returns a tuple with each index having the number of corresponding elements. So here, in simple terms, we are trying to ask the Python code saying that how to we say what is the shape of an array. So this is a method arr.shape. Okay. So in the same case, so we can go something beyond that also. The above example returns 2, 4, which means that the array has 2 dimensions and each dimension has 4 elements. So this is what we are trying to achieve when they say print array.shape. Okay. And we'll take one more examples. Create an array with 5 dimensions using ndim. We already talked about ndim in the previous session. Using ndim, using a vector with the values 1, 2, 3, 4, and verify that the last dimension has value 4. Right? Import numpy as np, array equals to np dot array of 1, 2, 3, 4, and ndim equals to 5. So here, uh, so the shape print array, that means, and we need to have this 5-dimensional array. So this is the 5-dimensional array, right? Representation, and print the shape of the array dot shape. Shape of the array will be like 1, 1, 1, 1, and 4. So this is type this is like an automated one. So we shape of the array, it will be defined in this format. But here what it is trying to do here is, see, when we say 1, 2, 3, 4, this is like in 1 dimension, and this is like in 2 dimension. Okay, then this is like in 3 dimension, and this is like in 4 dimension, and the last one is a 5th dimension. So it's like a 5-dimensional array. It is being represented, even though we are given as a single format, but it has to convert into the 5-dimensional array. So that's the reason we're given as ndim 5. Right? It's the same thing, but we're just trying to say what is the shape of the array. So this is new in this case. Earlier we have discussed the same thing, but what is the other way to reshape it? I've got one dimension, like a two-dimensional array or a single dimensional array, but I want to convert to one shape to another shape. That is called something called as reshaping. Numpy array reshaping arrays. So here what's happening is reshaping means changing the shape of an array. The shape of an array is a number of elements in each dimension. By reshaping, we can add or remove dimensions or change the number of elements in each dimension, reshaping from 1D array to 2D array. This is one of the example which we'll do right now. So what I've done here is importing input number as MP, that's common. Array equals to np dot array and given as 1, 2, 3, 4 until 12. But what I'm asking Python is you reshape the array to 4, 3, right? So that gives the elements, right? 4 is the 4 rows, 3 columns. 1, 2, 3, 4. 4 rows and 3 columns. So this is 1, 4, 7, 9 is column 1, column 2, and column 3. So we have given this like in the method. What we are trying to do here is, so here sorry, we are here. Yeah, 4, 3. So 4, 3 means 4 rows and 3 columns. So what is happening here is the shape of an array is the number of elements in each dimension. That is true. By reshaping, we can add or remove. So what we're trying to do here is convert the following 1D array. So this is a one-dimensional array. Absolutely right. With the 12 elements into, we need to convert a 2D array, right? The outermost dimension will have 4 arrays and each with 3 elements. Yeah, this is one array, single dimension array. This is one single dimensional array. This is one single dimensional array. This is one single dimensional array. But in this case, we want 4, 3. That means, so overall, it is a 2-dimensional array with 4 by 3. That's the reason we got a brackets over here, right? So in the same case, so this is like converting from 1D to 2D. We can convert from 1D to 3D. Okay. So here the example, convert the following 1D array with 12 elements into a 3D array. The outer dimension will have 2 arrays that contains 3 arrays and each with 2 elements. So don't need to get confused. Let me run this and show you. Okay. So what I've given is 1, 2, 3, 4, 5 until 12. So this is slightly tricky. Why? Because see, new array equals to array reshape of 2, 3, 2. Okay. So we need to convert to the 3-dimensional array. So see what is happening here is, so when I say 2, 3 means, so internally, so here it is picking up two values each, 1, 2, 3, 4, 5, 6. So that is what, two elements, and we got 3 rows, right? We got 1, 2, 3, right? 3 rows each. Again, here we are converting to 3D. So look at these brackets carefully. So when we talk about this, we got single opening and closing. We got the single dimension one. When we got 2, when we got this, we will call as a 2D array. The same case, look at this example here, the top one. And when we have this third one bracket over here opening and which has been closed over here, so now it is becoming as a 3-dimensional array, right? So that's a difference. So we need to look for the number of the opening brackets and also the number of the closing brackets. So that will define whether it is a 2D array or like a 3D array. So the 3-dimensional array or like a 2-dimensional array. So this one is a 2-dimensional array and this one is a 3-dimensional array, right? So the format which we need to give is in general, just for single dimension 1D to 2D conversion is just, we can say 4, 3. We don't need to give any other values there. But in this case, reshape 2, 3, 2. So we're giving this. So with that, it's giving these values. So just in case, if I say we don't have much values, but if we have more values, then we would have given. So we can also say 3 comma 3. We might say 3 comma 2. Let's see if it works. 3 comma 2. Let's see what it will happen. Yeah, but we don't have enough number of values. It's giving the same thing, but of course the original version is the correct one. Why? Because we don't have the number of values. We need to have enough number of values to represent in a proper format. Okay. What was the original format? Yeah, let me see. Yeah, that was correct only. Yeah. So yeah, this is what we have done, like an 1 2 3 4 5 6. Yeah, it's a 3D array. Okay, so once we have the more number of values, then we can give the shapes, or we also need to visualize the shapes. Okay, how the values will be displayed. So we need to have in our minds also, like based on that we need to give the shape. So there are few examples where if you don't know the proper sizing, Python can fix it by itself. There's a very good example I'm going to show. Uh, just bear with me. For example, can we reshape into any shape? Right? So what will happen? So here we are given as like an array of reshape of 3 comma 3. But look at this example. How many values are there? 1 2 3 4 5 6 7 8. We got only 8 values, but I am talking about reshaping of 3 comma 3. 3 3 are 9. We need 9 values, but we don't have 9 values. So that is the reason it is coming up with an error saying that value error, right? Cannot reshape array of the size 8 into shape of 3 comma 3. So that means we need to fix it. That means add one more value next to 8. So in this example, say, so what we have done is I just added just 9 here and reshape of 3 comma 3. So 3 comma 3 means 1 2 3 4 5 6 7 8 9. 3 rows and 3 columns, right? So 3 rows and the 3 columns. So that is what it's happening over here. So if I give anything something like 2 or something like that, it will definitely throw the error message. But however, here 3 2s are 6. It might work, but the thing is that here it didn't work in this case. Why? Because 3 3 are 9 values, right? 3 3 are 9. But here we have only 8 values. So that's the reason it says cannot reshape. So we need to make sure that what we're giving, okay, if I say 3 comma 3, definitely it brings up like in 1 2 3 4 5 6 and 7 8 9. So single dimension is been fed, and we get the 2D array over here with 3 rows and 3 columns, right? So these are all the rows, and these are all the columns, right? So let's okay, there is one more example which we came back with a copy and view also. So returns copy or view. Check if the returned array is a copy or a view. Okay, what we're trying to do, 1 2 3 4 5 6 7 8, all the 8 values were given into an array, and say print array dot reshape 2 comma 4 dot base. Okay, so let's say run. So yeah, it does provide the values 1 2 3 4 5 6 7 8. That means it's giving the values as it is, no difference. Okay, so we are not changing anything, we are not applying anything copy or shape onto it, nothing. The above example returns the original array, so it is a view, right? So we are not changing any values over here, we are not replacing any values, or we are not changing any values. Simply we are trying to say what will happen when we reshape 2 comma 4 dot base, and uh, and how it is being defined. That means whether it will treat it as a copy or a view. right? So uh, yeah, that was the same simple example. So let's make one more example like unknown dimension. As I told you, right, I don't know the dimension type. See, since here we got a value error, right? So how to avoid the value error, right? To avoid the value error, there is a concept called, okay, there is a concept called new array dot reshape of 2 comma 2 minus 1. So what I'm doing here is I'm adding the value, I'm assigning the values. Array equals to np dot array 1 2 3 4 5 6 7 8. Okay, so the concept here is new array dot reshape 2 comma 2 minus 1. So minus 1 makes a very good difference, saying that, so what we're trying to do, even I don't know how many dimensions are there, unknown dimension. So you're allowed to have an unknown dimension, meaning that you do not have an space, you do not have to specify an exact number for one of the dimensions in the reshape method. Okay, pass minus 1 as a value, and numpy will calculate this number for yourself, for us, for you, right? So convert 1D array with 8 elements to a 3D array with 2 by 2 elements. See how good is. So I don't know that how to convert into 3D, but I will ask Python to convert into 3D with just 8 elements. So n new array equals to array dot reshape 2 comma 2 minus 1. So it's 2 comma 2 will be like an 2 by 2, 2 rows, 2 columns it is making. And also from here to here, it's a single array. And from here to here, the double braces, that will be like an 2D array. And since we are talking about the 3D array, so the last opening and closing, see? So this will become the 3D. So minus 1 will make a lot of difference. Like an automatically it will calculate, okay, let's arrange in this particular fashion 1 and 2, 3 and 4, 5, 6, 7, 8 with the opening brackets and closing brackets, right? So that will change into convert into 3D array. But there is a note, we cannot pass minus 1 to more than one dimension. That's okay. So we got one dimension over here, then we are able to utilize it. If there is more than one dimension, we cannot utilize this feature. That's a drawback. But this is a very good example, like in minus 1, treating as minus 1 means, so it will automatically convert and it will display, right? So it's like I started it. Okay, we still got a lot of time. So flattening the arrays. Flattening arrays means converting a multi-dimensional array into a single dimensional array. We can use a reshape of minus 1 to do this, same concept. Convert the array into a 1D array. So what we are given here, array of NP or array, we got 1, 2, 3, and also 4, 5, 6. So simply saying that we are given as a 2D array here. The 2D array, I want to convert it. But what I'm saying here is new array, like array dot reshape of minus 1, print new array, right? Let me run this. See, it converted into 2D array from 2D array to 1D array. Okay. So convert the array into a 1D array. That means simply it's converting 2D array to 1D array. So that's what it's trying to do. So in that case, we are saying that a new array equals to array dot reshape of minus 1. So it is automatically converting into a single array, like in single dimensional array. So reshape works in this case also. We can flatten the array by converting multidimensional array into a single dimensional array. That's a good thing. So even if I add one more set over here, like 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12, something like that, then automatically it will convert to a single dimensional array. That's what I feel. Let's take add some more values like 7, 8, 9, right? And if I run the same thing, see what I've done is I've added one more dimension to it. Instead of having this yeah, it's I didn't give many brackets, even though if I want to give one, I can give one more bracket and say that it's a 3D, but it's giving an example. What I'm trying to say is, even though if I have one more dimension here and I'm using the reshape function here, -1, I'm still converting it to the single dimensional array. Just trying to give one more clear example, but we'll leave it to the original format. Otherwise, I need to change the text and everything here. So here, the 2D array has been converted to the single dimensional array. So it can be anything. That's what they're saying is flattening the arrays concept. So note there are a lot of functions for changing the shapes of arrays in NumPy, flatten. There is something called Ravel, and also for rearranging the elements, rot 90, flip LR, flip for. So this is a lot, but we are not going to look at all the examples. But that will fall under, these falls under the intermediate to advanced section of NumPy. So we are not getting into such a deeper section, right? So let's pick some examples of iterating. But before getting into iterating, okay, and let me know if anyone has got any questions so far. I'll pause for 10-15 seconds. Yeah. So far we have seen NumPy data types, array, copy versus view, shapes, reshapes. Okay. So we got a few more things to go, right? And then we'll be jumping onto the pandas. Okay. So we still got 10-15 minutes. I think I can talk about something called, I'll give one or two examples of iterating and one or two examples of joins. And see split. I think I got split examples also. The search, sort, and filter we'll see in this week 8. So let's get it on to iterating. Okay. Going in a good direction. Okay. So what do you mean by array iterating? NumPy array iterating arrays. So iterating means going through elements one by one. I think you guys have remembered the for loop, you know, for loop and a while loop. So for loop, the concept of for loops, we are going to use it here. That is nothing but iterating. That means we are going to in a loop format. Since we use the for loops, so it will keep going to and fro. Like for example, for x in array, print x. So this is nothing but iterating. So iterating means going through the elements one by one. As we deal with multidimensional arrays in NumPy, we can do this using basic for loops. That's what I'm trying to say. We're just using for loops. There's nothing much difference here. If we iterate on a 1D array, it will go through each element one by one. Example, iterate on the elements of the following 1D array. So import NumPy as NP, the same examples we're giving. Array equals to np.array 1 to 3. But here, instead of just using np new array or print array or something like that, so we are using the thing called for x in array. Okay, for x in array, print x. So what will happen the first time? It will print 1, then go back to the for loop. Okay, then pick the second value, then print 2, then go back to the for loop, then print 3. The same process, it gets repeated. In simple case, we're trying to print the array elements, right? That too with the iterative approach for loops. Same case, if I want to use a 2D array, all right? So here I'm using the 2D array, 1, 2, 3. So here to here is a single dimensional array. And we got a single dimensional array since we are using braces. So it goes to the 2D array. So same concept for x in array, print x, right? So here it is giving, or like it's printing the same values 1, 2, 3, and 4, 5, 6, but using the for loops. So it keeps on moving in the loop format, right? So we're using the for loops here. So that's how it prints a value. If we iterate on an ND array, it will go through n minus 1th dimension one by one. But of course, we are not going to use nth dimension, so we'll place some limit to it. Okay. To return the actual values, the scalars means nothing but the elements only. You don't need to get confused. The real values. Scalars means nothing but these values are the real values. So that's what we're talking about. We have to iterate the arrays in each array. Okay. Iterate on each scalar elements of a 2D array. So this is a 2D array, but this time instead of just with one for loop, this time I'm going to guess for x in array, then for y in x, print y. Okay. So it won't print in an array format 1, 2, 3, 4, 5, 6, right? It is printing in the normal sequence like in 1, 2, 3, 4, 5, 6. The reason is here is, so the whatever the iteration flow which we are giving, it is not in a simple for loop. If it is a simple just for loop, then it will definitely say that, okay. So if I say instead of the same case, if I replace, just let me copy it, and this time I'll say print x, and if I say run it, right? So what it is trying to do, it will try to do is, it will say 1, 2, 3, 4, 5, 6, right? So here what I've done is, I'm not going with any other additional for loop, but if I go with the normal style, like I got a for loop for x in array, and then again phi for y in x, and print y. So it's giving in this fashion. The reason behind this, the iteration, the for loop iteration is making the changes, right? So just trying to say 1, 2, 3, 4, 5, 6. Iterate on each real value elements in the 2D array. These are the 2D arrays. So we just need to know how it will behave when we use one for loop externally and one for loop internally, and how it's going to print the values. So this is what the method. It's not going to print in the single dimensional array or something like that. Okay. So it is going to print the actual real values 1, 2, 3, 4, 5, 6. Okay. The same concept. So iterating a 3D array. So here, but we're not going to multiple for loops here. But what's happening here is we got np dot array 1, 2, 3, we got 4, 5, 6, then 7, 8, 9, and 10, 11, 12. But we are asking Python to print the values, right? What will happen over here? So it's giving has 1, 2, 3, 4, 5, 6, right? Then again 7, 8, 9, and 10, 11, 12, right? So iterating 3D arrays, what's happening here is, so it's a 3D array. How do I say that it's a 3D array? Number of opening brackets and the number of closing brackets. So based on that, I'm saying it's a 3D array, right? So if I remove one from here, and if I remove one from here, so it is not a 3D array, right? So that's the reason I need to make sure that how many open brackets are there, how many closing brackets are there, right? So based on that, in a 3D array, it will go through all the 2D array elements, right? So internally there are the 2D array. This from here to here, it is one 2D array. From here to here, it is one 2D array, right? And on top of it, we got the brackets, right? So iterate on the elements of the following 3D arrays. So it's been arranged in the a neat fashion. So this is one 2D array. This is one another 2D array, right? So again, we can look at this example, and on top of it, the 3D. So in a 3D array, it will go through all the 2D elements. Yes, iterate on the elements of the following 3D array. Yeah, that's fine. So this is one of the example. And let's take one more example, okay, before getting into ND iterate. So that's a different concept. So I'll stop at this line number 32. Yeah. So to return through the actual values, the scalar, we have to iterate the arrays in each dimension. Example, iterate down to the scalar. So import numpy as NP. So what we're trying to do is here is we got a for loop X, and again for loop for Y, X in array, X in array, and then Y in X, then for Z in Y, and print Z. So in simple, it is going to give all the real values, or like it will simply print the values inside the arrays. Neither it will arrange in a single dimensional array or two dimensional array or the three dimensional array, nothing like that. But when we assign the for loops in this loop format, iterative approach, so those will print only the values of the arrays, right? So that's a thing to return the actual values. So this is what we meant to say, actual values or the real values. We have to iterate the arrays in each dimension. So just to find out what are the actual values inside the arrays, we don't want any brackets. So then this is a method to bring all the values and display them, right? So I think since I do have some more examples, but from here we can go to the next session. We got something called ND iteration. That means we want to use the functions. Okay, there's a function called ND iterate. I want to use it. So that's one, and with the different data types also, right? Different data types, and there is something with sizing. Okay, and after that we do got something called enumerated iteration, and yeah, ND iterate. There is a function, yeah, enumerate, and then we jump onto the concept of joins, right? We got something called joins, and we got something called split. How to join the arrays and how to split the arrays. So here, when I say 1, 1, 2, 3, and 4, 5, 6, there is an option like an H stack. For joining purpose, there is something called V stack also. This is joining the arrays. There is something called split the arrays. Okay. If you want to split the arrays over here, there is an option called array underscore split. So it's going to split the elements. So we will talk about this thing in the next session, and we're almost there to complete the numpys. So in the later sections next week, probably I will cover this numpys remaining portion, and then we'll proceed to what I say, pandas. Okay. So value to be converted. I think we have discussed a lot today. Yeah. So here, what I will do here is I'll copy this and iterate. Let me pull out these elements. So we selected the week 7 from here, and probably 33, right? 33. Okay. So let me give over here. Okay. So we're going to add something over here, week height, and we'll be adding something called iteration, right? So we'll talk something about iterating, join, split, search. Those won't take long, maybe half an hour, something like that. And then we'll continue with pandas. Okay, right? Pandas. So we'll start pandas next week, and then we'll continue to week 9 also pandas. And week 10, we'll talk about the visualizations, how we can achieve in Python exclusively instead of using Tableau or Power BI, ClickSense, there's reporting tools. Instead of using those reporting tools, we can use Matplotlib and Seaborn. They are the options present in Python itself. We don't need to request the client to please buy Power BI, please buy ClickSense or Tableau software. So they don't need to buy any software. Simply we can utilize the inbuilt functions in Python itself and then show the visualizations concepts to the users. The client will be happy. They'll be saving a lot of money. Just using Python, we can do a lot of things. So next week we'll be covering a lot many things, especially the week 8 and week 9 we'll be covering complete pandas, and week 10. So 3 more weeks. So everyone will be able to understand all the concept of Python, right from the beginning basics to Numpy pandas. So these are all actually the key topics. That's the reason I'm taking time. Otherwise, we can rush together also. But once we understand the concept of Numpy and pandas, and someone wants to learn about the machine learning or deep learning or whatever, so these are all the basic foundations. Without these basic foundations, it will be impossible. That's what my intention is. So if you have got any queries and all, you can still send me the questions on the WhatsApp group. Okay, so let me stop the pause the recording.